Welcome to this video where we'll explore dropout regularization in neural networks, a powerful technique to prevent overfitting in machine learning models. Let's start by understanding the problem dropout aims to solve. Overfitting. In machine learning, overfitting occurs when a model learns the training data too well, including all its noise and peculiarities, and performs poorly on new, unseen data. Now, let's visualize a simple neural network architecture. In a standard neural network, we have multiple layers of neurons. Each neuron receives inputs from all neurons in the previous layer, computes a weighted sum, applies an activation function, and passes the output to the next layer. The connections between neurons represent weights, which the network learns during training. Now, let's introduce dropout regularization. Dropout is a technique where during training, random neurons are temporarily removed or dropped out from the network with a certain probability, typically 0.5 for hidden layers. Here's how it looks. Notice how some neurons and their connections are temporarily disabled during training. Let's understand how dropout works during the training and testing phases. During training, a different set of neurons is randomly dropped in each iteration, forcing the network to learn more robust features. During testing, however, no neurons are dropped, but all neuron outputs are scaled by the dropout rate to maintain the same expected output. Let's briefly look at the mathematics of dropout. For each neuron, we apply a dropout mask using a Bernoulli distribution. During training, we multiply the neuron's output by a binary mask that's 1 with probability p, key probability, and 0 otherwise. During testing, to ensure the expected output remains the same, we scale all neurons' outputs by p. So, what are the key benefits of dropout regularization? The most important benefit is preventing overfitting, especially in large networks with many parameters. Dropout effectively creates an ensemble of many different networks, improving generalization. It forces the network to learn more robust features that are useful in conjunction with many different random subsets of other neurons. Let's look at a practical example of how dropout affects training performance. This graph shows the training and validation error over epochs. Without dropout, training error continues to decrease, but validation error increases after a certain point, a clear sign of overfitting. With dropout, both training and validation errors decrease together, leading to better generalization on unseen data. Here are some practical tips for using dropout effectively in your neural networks. Typically, use a dropout rate between 0.2 to 0.5 for hidden layers and a lower rate of 0.1 for input layers if needed. Consider combining dropout with other regularization techniques like weight decay for even better results. When using dropout, you might need to use larger networks with more neurons per layer to maintain model capacity. To conclude, dropout regularization is a simple yet powerful technique to prevent overfitting in neural networks. By randomly deactivating neurons during training, it forces the network to learn more robust features and acts as an ensemble of multiple networks. Next time you're training a deep neural network, consider adding dropout to improve its generalization capability.